Hello everyone, welcome to YourPedia Education. So basically today we are going to discuss the past paper 2023 paper of ISRO, right? And we are discussing only the technical part, non-technical part will be done by the separate tutor. So we are discussing only 80 question of that one, how you can solve that and what are the answers for that correct answers for that questions, right? Okay, which of the following is given that the following matrix is a singular matrix, find the value of x. If this matrix is a singular matrix, what do you mean by the singular matrix? Whenever you have a matrix that is a singular matrix, it means the determinant of that matrix should be equals to 0. So if we are talking about a singular matrix, the determinant of a singular matrix is 0, right? See, if I take the determinant of this matrix, that matrix is 4, 2x, 0, 4, 0, 2, 12, 6 and 0, right? If you take its determinant, that determinant should be equals to 0, right? So expand this one. So first I am expanding this plus minus plus. So 4 times, when you multiply 0 with 0, that is 0, then it will be 12, 6 into 2, then minus 2x times, when you multiply it here, that will be 24, and then the last term is 0 equals to 0. So what we are seeing here, that is 48 minus that will be minus, that is going to be minus here, plus 48x is equals to 0. So x value is going to be 1. So what will be the answer? The x value will be 1. So only when your x value is 1, then only this matrix is singular matrix. Next, okay, this is given that the eigenvalue of a matrix, that is a matrix which is 3 cross 3 matrix, are 1, 3 and 5. You have to find the eigenvalues of a cube. So basically we know that property, if a matrix A has an eigenvalue of lambda, then a cube or a to the power n will have the eigenvalue a to the power, lambda to the power n. So basically if I have the eigenvalues of a matrix, that is 1, 3 and 5, then a cube will have the eigenvalue 1 cube, 3 cube, 5 cube. 1 cube is 1, then the second 2 cube is 27 and 5 cube is 125. So which one is the answer? The answer will be C. Next is we have to find its derivative is equals to. So basically this is this one. First we are talking about this inside function, that is x minus x cube by 3 factorial, then plus x to the power 5 by 5 factorial, then minus x to the power 7 by 7 factorial, like that. So we will have we have this equation, right? This is a power series expansion of what? This is having odd term, so this will be the expansion of sin x. So basically he is asking for the derivative of sin x. He is not giving it directly, he is giving that thing in the Maclaurin series or Taylor series expansion of sin x, or you can say the power series expansion of sin x. So when you take the derivative of sin x, that is become cos x. So answer will be C. Next is the value of integration. We have to find the value of this integration. So basically we know that this is an impulse function delta t here. This is an impulse function delta t here, which is multiplied with sine of t by root 2 dt. So basically first we use the impulse property. What was that property? If you have a f of t function and you multiply this function with the impulse signal, that will result the f of 0 multiplied by delta t. So we are going to use this property here. So it is going to be integration minus infinite to infinite delta t, then it is sine of 0 by root 2 dt. So sine 0 is 0, right? So when your sine 0 is 0, that means this total integration is becomes 0. So what will be the answer? Answer is C here. Okay, next. Which of the statement is true? Trigonometric Fourier series of an even function of time contained only DC term and sine term. So whenever we are talking about trigonometric Fourier series of even function means that will contain even function, that will contain what? DC term as well as cosine term. And whenever you have a odd function, that will contain only sine terms, right? That A option is not correct. Then move to the B option. Trigonometric Fourier series of an odd function of time contain only cosine term, that only contains sine terms only. This option is not correct. Next, trigonometric Fourier series of an odd function of time contain DC term and sine term. See, whenever we are talking about odd function does not contain the DC term, that will only contain the sine term. So this option is not correct. The trigonometric Fourier series of an even function is contain only DC term and cosine term. That will be the answer for this question. Next one is what? Yeah. If a random communication signal has a PDF, the PDF of the signal is given to you, then we have to find the value of, the relationship between A and B. See, whenever it is a valid PDF, then what we can say, the integration from minus infinite to infinite P of x dx should be equals to 1. So if we integrate, I am breaking this integration into two parts due to this mode function. So we can integrate it from minus infinite to 0 e raised to the power that this modulus function can be written as what? That will be minus x for x less than 0 and plus x for x greater than 0. So we are going to use this property. So whenever you are integrating from minus infinite to 0, it means the x value is negative, then this modulus function is going to be minus x. So it is become 2a e raised to the power bx then dx. Then again plus 2a outside, integration 0 to infinite, right? Next one is e raised to the power minus bx dx. So now it is become 2a, when you integrate this one, that is b, and that will also 2a upon b when you integrate that one. So it is become 4a upon b. And if it is a valid PDF, we calculate this integration first. If it is a valid PDF, then this value should be equals to what? 1. So what we can say? The 4a upon b is equals to 1. So what will be the relation? B is equals to 4 alpha or a, right? So the answer will be B. Yeah, from here it should be B is equals to 4a. Right, the noise phenomena arranged in isko, we can say this question is difficult level, because we generally don't studies this type of noises in terms of frequency. But if we come out to with the noise phenomena arranged in the order of their dominance when they plotted as a function of increasing frequency. See, the flicker noise is dominated at low frequency because it will be inverse of the frequency. White noise is spread uniformly across all the frequency, and transient time noise appears at high frequency. So what we can say, the first low frequency flicker noise, then white noise, then transient time noise. So answer will be B here. Yeah. When a carrier is AM modulated by 3 sinusoidal tone signals of percentage of modulation 50%, 50% and 20%, the effective modulation index. So effective modulation index M is equals to under root of M1 square plus M2 square plus m3 square, right? So basically m1 is how much? That is 50%. 50% means what? 0.5 square, right? Next is also 50%, so 0.5 square. Next is also next is 20%, so 0.2 whole square. So it's going to be 0.25 plus 0.25 plus 0.04, right? So when you add this, this is become 0.75, sorry 57. So the sorry 54 or 57, yeah 54, not 7, because that will be 0.25 plus 0.05, 0.5 plus 0.04, that will be 0.54. 8 signal, each band limited to 2 kilohertz and sampled at Nyquist rate, are converted into binary PCM signal using 256 quantization levels. The data rate of TDM signal will be, so first thing what we have to take, each is band limited and sampled at its Nyquist rate. So first we calculate the sampling frequency, that will be twice of the message signal frequency, because we are sampled the signal at Nyquist rate. So it is become how much? 4 kilohertz. That is your sampling frequency, and each sample will be represented by how much bits? We can calculate the number of bits from the quantization level. So number of bits required for each sample, that will be n, and it can be represented as log of 2 base L. So it is log of 2 base L is how much? That is 256. So when you take this one 256 log 2 base 256, that should be 8. So we got that each sample is represented by 8 bits. So in TDM we will have 8 signals. So it means what is the data rate? So we are collecting how many samples from how many bits from each signals. We are collecting 4 times 8 bits. 4 times means that this FS represents what? Samples per second. So 4k samples per second we are receiving, and each sample is represented by 8. Each sample is represented by 8 bits. So what it's meaning? We are having from each signal we are having 4 times 8 kilobits, right? kbps you can say, but we are having this is from 8 and we are having 8 signals. So what will we have? Multiply by 8. So that will be the data rate in kbps. So 64 into 4, that will be 256 kbps. Yeah. Bandwidth occupied by 8 PSK modulated signal when each of I, Q and C data stream which form a N-type IQ toggle at a rate of 200 Mbps. So IQ toggle rate is 200 Mbps. The total rate will become 3 times 200 Mbps means 600 Mbps, and 8 PSK having 3 bits for each symbol. So what we can say, the symbol rate will be 600 by 2, 200, and the minimum bandwidth of a PSK signal, that will be equals to the symbol rate. So what we can say, that will be 200 Mbps or megahertz, right? Answer will be B here. Given that C and DR of a 256 QAM signal operated at 12.5 mega samples per second is 100 dB hertz, right? The value of EB by N naught, we have to calculate the EB by N naught. So what will be the formula for EB by N naught? EB by N naught is equals to C and DR 10 log of 10 base the data rate. When you replace these values, we will got 100 minus 80, that is 20 dB. So what will be the answer? The answer will be 20 dB. Okay. Return loss of a standalone antenna is 10 dB one 6 dB attenuator is with return loss of 40 dB is connected at the input of this antenna. Okay, what will be the approximate return loss of antenna plus attenuator? Attenuator has a return loss of 40 dB. So when you are calculating the total return loss, that will be return loss of antenna plus 2 times the return loss of the attenuator. So what will be the answer? The answer will be 22 dB. That is in dB. Which parameter of a semiconductor device exhibit positive temperature coefficient? So whenever we are talking about positive temperature coefficient, it means when you increase the temperature, which value will increase? That is the meaning of that one. See, whenever you are increasing the temperature, reverse leakage current will increase, right? It will increase, right? Reverse leakage current or reverse saturation current will increase, will double at 10 degree rise in temperature, right? Forward voltage will decrease and breakdown voltage generally slight positive coefficient, but varying by the types, right? So what we can say, there is a one parameter, that is reverse leakage current or reverse saturation current, that will be double every 10 degree rise in temperature, right? If transistor operated in the middle of DC load line and increase in the current gain, the Q point will be moved. So basically when you draw the transistor characteristics, that transistor characteristics are look like this one, and this one is your DC load line. So let us take your Q point is currently lying here, right? So this is your IBQ, and at this particular point this is your ICQ, and this is your VCEQ. So basically this IBQ is independent of the beta. Whenever I increase the beta, it means IC will increase. IC will increase, that means your Q point should be shifted towards the left side, right? VCQ is also increasing. So IB, so beta is higher, IB is higher. So so what we can say, that will be shifted on the up on the load line, right? It will go up on the load line. The relationship between ID and VGS in the MOSFET in the saturation. See, in the saturation, the MOSFET current equation, ID is equals to 1 by 2 mu n into C ox W by L VGS minus VTH whole square, right? So that relationship is what? Quadratic relationship. Answer will be B. Which of the which is the identity for convolution operation? See, basically whenever he is talking about identity for convolution operation, see, we have, let us take, we have a xn function, and if we convolve this with any function, that will result the same signal xn, and that signal is delta n. So what we can say, the delta 1, the impulse signal is a identity for convolution operation, right? So answer will be C. A random variable x has a uniformly distributed between -4 to 1. So we have a random variable that is uniformly distributed between -4 to 1. So this is a uniformly distributed random variable. If I calculate the value here, that will be 1 over 5. So this is the PDF of a uniformly distributed random variable. He is asking about the mean. So whenever you are calculating the mean, let us take, this is A, this is B. The mean of a uniform random variable is B plus A divided by 2. So whenever we add these two, that is 3 by 2. So mean is going to be minus 1.5. And whenever you calculate the variance of a uniform random variable, the variance is B minus A whole square divided by 12. B minus A whole square divided by 12. So that will be 5 square divided by 12, 25 by 12. So the answer will be A for this question, right? So these are directly formula based questions. See, if I come to this ISRO part, that is not that much difficult, but here some questions are, you can say, which we didn't study in GATE and everywhere, right? These type of question he will ask you that are related to communication, that are related to advanced communication, microwave, like that, right? This question, the transfer function has the pole, it is having how many poles? 2 poles, that will be lie at -3 and -3. The answer will be C. That's it. Yeah, LTI system will minimum phase. See, he's talking about because we generally studied about the LTI system, that is minimum phase. We are studying in continuous or S domain. He is asking about the Z domain. So he says that all the pole lie inside the unit circle. See, whenever we are talking about the minimum phase system, that means it's all pole and zero should lie under the unit circle or lying on the left half of S plane. So what we can say, all the poles and zero lie inside the unit circle. The answer will be D here. A real sequence 8-point DTFT is given to you. He is asking, see, some values are given to you and one value he is asking. So this for a real sequence, the x of k is equals to x star of n minus k. That means complex conjugate of n minus k value. Let's take, we are calculating x of 6. So x of 6 is basically x star of 8 minus 6. So it means that will be the complex conjugate of x2 value. So x2 value is 3 plus j. So that will be 3 minus j. So remember, these are the property based, direct property based questions are here. Okay, he is asking which of the following is not true, given that this arrow represents the Fourier transform, this star represents the convolution, right? Okay, first this will, yeah, this is the linearity property of Fourier transform, this is true. Second, if you are having n minus n naught, that will be multiplied by this value. No, that's not correct. This option is not correct. It should be e raised to the power j n omega naught x of e raised to the power j omega naught, and this should be minus here, not plus. This option is not correct. It means that will be the answer. This is having mistakes here, right? Next is correct, next is also correct, right? These are the property of Fourier transform. Yeah, butterfly diagram taking radix to decimation in FFT. We generally didn't study these things in GATE exam and other exam, for other exam, but in ISRO it is important. Assume that 5 stages of signal flow graph are indices as M1, M2, M3, M4, M5, where 5 is the last stage. Which 5 stage has butterfly of the form of this one? Okay, see, basically W6n, that will be represented by like this, that will be appears only at 3rd, 4th and 5th stage. Rest of the state it will not appear. See, Twiddle factor like this will appear at the last stage. So that will appear in the last stage. That means it will appear on which starting stage, that will be depend on this factor Wn6, that will be available at the 3rd and 4th and 5th stage, right? Okay, next question, if A and B are 8-bit right shift register connected as shown in the figure, the initial value of A and B in hexadecimal is B2, 0F respectively. The value of A in hexadecimal after 8 clock pulses. See, this is these two registers are 8-bit right shift register. They will shift the sequences towards the right. So if you convert this B2, first convert this B2 into binary. B means what? B means 11. So 11 means 8, 2, 1, 11. Yeah, this is 11 and this one is 2. So the first is B2, then B is 0B, 0F. 0F is 0, 0, 1, 1. So first we convert the content of the given register into the binary. So what we got here initially what we got here, register A has value 1, 0, 1, 1, 0, 0, 1, 0, and the next register will have the value 0, 0, 0, 0, 1, 1, 1 and 1, right. When you apply the clock, these values are shifted towards the right and the last value will come first. So I am writing that thing here. So currently in the starting, before applying the clock, the content of the register is look like this one. Now the last one will come first and 1 bit are shifted towards the, so first clock we will got 1 1 0 1 1 0 0 1 1 0 0 0 0, one more 0 and then 3 1. Now for the second clock, what happened? This last one will come into first, 1 1 1 1, then 0 1 1, then 0 0 1, then 1 2 3 4 5 zeros and 2 ones. Second clock, then third clock, move to the third clock. So the third clock, what happened? This last one will come to the first again. So 1 1 1 1 1 1 0 1 1, then we will have 0 0 1 1 2 3 4 5 and 1, right. Next last, then fourth clock, the last one will come here, then 1 1 1 1 1, then 1, then 0, then 1 1, then 0 0, then 1 and the 5 zeros. Yeah, last, not last, that is fifth clock. After fifth clock, last 0 will come into first, then 0 1 1 1 1 1, then 0, then 1 1, then 0 0, then 4, then 1 and then 4 0. Again the last 0 will come in the sixth one, so 0 0 1 1 1 1, then 1, then we will have 0, then we will have 2 1, we will have 2 zeros, then 1, then 3 zeros. Now convert this one into hexadecimal, right. You will get the content of which register he is asking about, the content of A1, A register. So that will be 2 and this will combine together. So the content of is 3. Yeah, this is 3 and this one represents 8 4 12 13, 3C. I think 3E, 13 is E, it is E, yes, 3E is the answer. Yes, each clock we describe here, so you will check that. We will have the content of A like this, yes, 3 and 1 1 1, 8 4 2 12, yeah, 14, you know 13, that is 14, yes. So we will code this one. So this is 3 and this will represent the 14, right. 8 4 12 12 plus 2 14, 14 is E. So 3E will be the answer for this question, D. What is quantization noise power of a n-bit uniform quantizer? N-bit uniform quantizer with full scale input voltage. See, quantization noise power, the quantization noise power is delta square by 12, right, for a uniform quantizer. Delta is the step size and delta will be how much? So if you calculating the delta, that will be full scale value, that is 2b, divided by number of levels, that is 2 raised to power n. Now replace that value here, so the noise power is going to be 2b divided by 2n, 2b divided by 2n whole square divided by 1 by 12, 2 raised to power n. This is 2 raised to power n, not 2n, right? Remember that one. So what we can write it here, that is going to be 4 b square divided by 12 2 raised to power 2n. So it is become yeah, then when you can cancel this 4 by 3, you will go to the value is A. The answer will be A, not C. Answer will be A. B square divided by 3 2 raised to power 2n. That should be 3 here, not 12, right? Answer will be A for this one, right? Okay. Next is simplify the Boolean function in the POS form. So when you simplify this one, so you have to make the K map. That will be the easy, because he is asking about POS form, so we have to put the 0 values. A, B, C, D, 0, 1, 1, 0. Right. So you can check it here 0, because it is summation form, means this is mean terms, right? You have to write the max terms. So max terms are those which are not available in your mean terms form. So we can say 0, we will put 1, we are not putting the 1, we are only putting the zeros. Then 2, it means here 0, then 2, then 3, 3 is 0, 4, 5, 6, 7, yeah, and 8, 9 and 10 is 0, 9, 10, 11 is 0, then 12 is 0, 13 is available, 14 is 0, 15 is available, like this. So now make a grouping here. We will make a group like this, and this group is like this. Directly you can write the expression from this one. So when you go for this 4 group, that will become the B value is not changing, that is fixed. So that will be B, because we are writing the max term expression. Then POS expression, that B, because 0 will be represented by variable and 1 will be represented by the complement of that variable. From this side we can check it D dash, right? D is constant, so 2, 1. Now go for this two expression, that is A dash plus B dash plus D. So what will be the answer? Answer will be D here. H1 is given to you, H2 is given to you. If they are cascaded, and their effective HZ is, find the possible value of A, B, right, like this. So first we have to write the H1Z, the Z transform of H1. That will be A upon 1 minus B1 Z inverse. Similarly H2, the second one, H2Z, that is also A upon 1 minus B2 Z inverse, right? When you multiply these two, that result, because they are connected in cascaded, so HZ, the overall transfer function HZ, that will be H1Z into H2Z, right? So H1Z is going to be A square divided by 1 minus B1 Z inverse 1 minus B2 Z inverse. It should be equals to 4 upon 4 minus Z to the power minus 2. So what I take the 4 out. So it is become, I am only writing the left hand side, that is become 1 upon 1 minus 1 by 4 Z to the power minus 2. It should be equals to this one. So when you compare this one, take the factor of the denominator. If I take the factor of this denominator, I can write it 1 upon 1 minus 1 by 2 Z inverse and 1 plus 1 by 2 Z inverse, right? And compare this one with this one, 1 minus B1 Z inverse 1 plus, that is also minus 1 minus B2 Z inverse. So when you compare here, A is going to be 1, right? You can take B1 as a 1 by 2 and B2 as a minus 1 by 2. So these are the values of this one. Answer will be C. A is 1, B1 is 1 by 2 and B2 is going to be minus 1 by 2. Yes, next one is The input to a digital circuit are the signal A, B, C. A bar, B bar, C bar are not available. The 5 volt supply and the ground can be used as a logic 0 and 1 input respectively. To implement this function, B bar, C bar plus AC bar using 2 1 to 1 mux, minimum number of mux are required. See, basically whenever you are designing that B bar, C bar, AC bar, so what we can take, B bar plus A, and I'm taking that C bar out, right? I think this question is a little bit different here. Oh, to implement, we implement this one, that is A C bar and B bar C. Okay, there is also C bar. Okay, then it will require this one. This solution is not correct, right? This is for A C bar and B bar C. This question is having different value. I think there may be a printing mistakes in this one. You may check this one. Okay, if you are implementing A C bar plus B C, then what we can do, we can take a 2 cross 1 mux here, and we can give the C input, that will take A here, that is going to be A C bar. Then we generate the B bar by providing the B as a this mux is working as a NOT gate, then it will be going to be A C dash plus B dash C, right, like that. Otherwise this will have the different notation. It is required 2 if we have this one A C dash plus B dash C, it is required only 2 mux, right? If it is having, I think it will require 3 mux, 3 to 4 mux. You can check it accordingly. You can implement like this we did here. Which of the following is not true in VHDL? In VHDL, mostly one question they will ask, you will left that topic also, right? If you are good enough in VHDL, you can attempt that question, and otherwise you can leave that question. So basically signal assignment can be used inside the function. See, basically whenever we are talking about the VHDL, inside the function we never assign a signal. Signal will be assigned before that function, right? We assign every signal before the function. Inside the function we generally do the operation on that function. So answer will be A. A 4-bit unipolar DAC with 10 volt reference voltage feed to the input of a comparator whose threshold voltage is set to be 7.5 volt. When DAC counts from 0 to reaches 8 volt, the comparator shows the threshold crossing wrongly. It found that one of the DAC input bit is stuck at 1. What bit will be which bit? So first we calculate its resolution. Resolution is 0.67 and yeah, 0.625, you can say like that. 0.625 is the resolution, threshold is 7.5. It means expected crossing point will be 12. When you divide the 7.5, that 0.625, that will be 12. So when you compare this one, that will be 110. So when you do this all the calculation, the B note stuck when you have 1101, but that is having 9 decimal equivalent, that will not. When you have 110 plus this one, that will be 1010, means 10. Then you will go to 6.25, that will not stuck. That 110, when your B2 stuck to 1, B2 stuck to 1, then we will go to 1100, that means 7.5, that will be the answer, right? Because if your B3 stuck, B3 means 110, that will be no change. So B3 cannot be stuck. So what will be the answer? Means your B2 can stuck at that particular one, right? In this question, this is also a good question. The resistor R1, R2, R3 are connected in series across a voltage source V. R3 is connected in parallel with R3. Yeah, okay, R4 is connected in parallel with R3. R1 to R4 are to be chosen from the available resistors value. We have to choose the values from 3, 6, 10 and 15. What will be the ratio of minimum current to the maximum current to the minimum current of R1? See, basically if I talk about the voltage will remain same, so it means current is directly proportional, inversely proportional to the resistance. So we try to find the maximum resistance and minimum resistance. The ratio of that one will give you the current ratio, right? Okay, so first we have to find the maximum resistance. Resistance will be maximum whenever you choose that this is 15, this is 10, this is 6, and this is 3. Whenever I choose these value, because in series we add the resistance, in parallel we divide that resistance, so it means when you are using the maximum resistance in series, you will get the maximum value of resistance. So in that case, R equivalent is going to be 15 plus 10 plus 6 into 3 divided by 6 plus 3. That is going to be how much? 1525, and that will be 227. This is the maximum. If you calculate the minimum resistance, then what you have to do? You have to choose 3 here, 2 here, here is 15 and 10. Like if I choose that the minimum resistance R equivalent minimum, that is going to be how much? 3 plus 2 plus 15 into 10 divided by 15 plus 10. So we will quote how much? Parallel, that will be 15. So when you take the ratio, that will be 1.8. Next, a system is described by the difference equation. This system will be stable. So what we have to do, we have to find the characteristic equation of this system. That will be y of n minus 1.8 y of n minus 1 plus 0.72 y of n minus 2 equals to 0. Right, converted it into z transform, so z square minus 1.8 z plus 0.72 is equals to 0. Right, when you solve this equation by using this b minus b plus minus under root of b square minus 4ac divided by 2a, then it will be give you two values, right, like this. That will be 1.2 and 0.6. It means one pole is lying outside the unit circle, that make this system unstable, right? That is the answer for this question. Next one is, this is also a very good question. The state transition matrix state transition diagram the state transition diagram of a for the diagram given as. So basically this one is given to you, you have to draw the state diagram. So first thing, what we'll observe here, this on the basis of this S value, it will select one of the Q or Q dash, this is Q dash here, one of the Q or Q dash, and that will be connect that value to this input. So what we can say, that the T is equals to what? T is equals to Q when your S is 0, and T is equals to Q dash when your S is 1. Right. Let us take from this state diagram, let's take first state that Q is 0. We are standing here, Q is 0. Right, and your input is coming, S value is coming to be 0. So whenever your Q is 0, S is 0, Q is 0, S is 0, right? It means T is going to be 0. So in the next state, whenever your T is 0, it will not change its state, right? It will remain on the same state. You know that the truth table of T, that is Qn plus 1, next state will be equals to Q, and when your T is equals to 1, then it will become the complement of the previous state. That will be the truth table of the T flip flop. So what we are observing here, when your S is 0, Q is 0, so the state diagram will start, or next state will coming out to be same. So that means it will coming back to the same state. It will coming back to the same state. So these two diagrams are not correct. This one may be correct. Now next thing, whenever you have S equals to 1 and present state is 0, so it means that will be T connected to the 1. it means the next state will be the complement of the previous state. So it will be go to the next state. It will be go to the next state. Yeah, that's correct. Now come to the second question, second condition. When your Q is 1, let's say Q is 1 this time. So if your input is coming out to be 1, so it means Q dash is going to be 0. So no change in your state. It means that will come into the same state. So this answer is not correct. D answer is correct for this question. So D will be the answer. You can check it from the characteristic table, or you can say the state transition table of this circuit. Given a single 3x8 active high output decoder, what is the minimum number of 3 input OR gate required to implement a full adder? That will be 4, right? 2 for the 2 OR gate for the, you can say, sum and carry. When you combine sum and carry, that will be 8. Oh, sorry, 4 gates are required. Okay, next. In the figure, find the value of this one to realize the function f is equals to a b bar. So first thing you have to remember that this should be MSB. We have to take this as a MSB, and this is LSB, C is LSB. So first we make a table for this one. I already make that table. We're taking B here, A here and C here. That will be the combination. And what we are seeing from this function that is f is equals to a plus b dash, right? So it means this function f is going to be 1 when your b is going to be 0, because here it is b dash. So take all the values where your b is 0 and your output will be 1, right? For 4 cases. Next, output will be 1 when your a is 1. A is 1, 2 cases is covered inside this one and 2 cases is here. So I put these 2 cases as 1. Only these 2 cases we got the value as 0, right? So this will connect it with 0, 1, 2, 3, 4, 5 and 6 and 7. So we will got the value 1, 1, 1, 1, 1, 0, 0 and 1, 1. So answer will be A for this question. Yeah, next. Which of the following is true for signal traveling through a waveguide? So whenever a signal is traveling through a waveguide, its guided wavelength will increase. Its guided wavelength will increase longer than the free space wavelength, right? That will be the formula for the guided wavelength. Okay, for a match junction S parameter, which of the following is correct? Right, which of the following is correct? See, basically this S11, S22 will represent the reflection coefficient. Whenever you have a match line, match means your reflection coefficient should be 0. So S11 will be 0. Oh, that is not the solution. So you should remember that S11 is 0. Which of the following transmission mode is supported by a strip line? Strip line, when we are talking about the strip line will always be supported a TEM mode, right? For a directional coupler, these questions are from the microwave engineering. Directional coupler, incidence power, output power, forward coupled power, reverse coupled power. The directivity of a directional coupler will be defined as the PF, forward coupled power, divided by reverse coupled power, right? That will be the answer is A. Magic T can produce, magic T is always produce either the sum or the difference of the signal, right? It will depend on the phase shift between the signals, right? The cutoff frequency of TEM mode. See, the cutoff frequency of a TEM wave is 0. That is DC. Answer will be B. Whenever we are talking about the EM wave, the frequency should be 0. Cutoff frequency should be 0. That will be for DC signal. The transistor oscillator FET BJT are used. Instability is achieved by positive feedback. Whenever we are talking about the oscillators, we will provide the positive feedback to get a sustained oscillation, or you can say the instability. In a 3-stage cascading amplifier, each stage has a gain of 10 dB, noise figure is 10 dB. So first we convert this 10 dB into normal. So gain is going to be how much? 10 raised to power 10 divided by 10, that is going to be 10. Noise figure is also going to be normal is 10. So when you got that one, you can directly use this formula to calculate the total noise figure. Noise figure 1 plus noise figure 2 minus 1 divided by Z1, noise figure 3 minus 1 divided by G1, G2, and that will be going to be 10.99, right? So answer will be A, not D. 10.99 will be the answer. Operating frequency limitation for a bipolar semiconductor device due to, see, basically whenever we are limiting the operating frequency at higher frequency, the gain of the transistor will decay due to the junction's parasitic capacitance, right? So junction parasitic capacitance will limits your operating frequency, right? Resistance. Which of the following offer highest speed of operation? That will be enhancement type MOSFET. Gun diode operated at a high frequency, it will offer a negative resistance device. Compared to silicon, gallium arsenide semiconductor offers an advantage. It is having higher electron mobility, higher frequency of operation, lower leakage current, but there is all of these one, but its band gap is higher as compared to silicon, and it is costly as compared to the silicon. That's why. Calculate the approximate power added to the efficiency of a power amplifier. That DC voltage is given to you, DC current is given to you, AC signal is 0 dBm, right? Okay, first we calculate the DC power, that is VDC into YDC. The power will be 40. Then convert the input power, that is in dBm, we convert that into the normal power, that is 0.01. For the output power, we calculate the output power from the given data. Output power is 1 volt, because he is saying that the output power is 30 dBm, right? So that will be going to be 1 volt. Then added power to this difference is how much? We have to calculate the approximate power added efficiency. So when you calculate the added power will be 1 minus that 0.99 volt, and when you are calculating the efficiency, added power divided by DC power, that will 0.99 divided by 40, that will be 2.5%. Which of the following class of amplifier provide the highest efficiency? That will be class F amplifier, will provide you the 80 to 90% efficiency. Compared to linear power supply, SMPS will offer higher efficiency as compared to normal, right? What are the different circuit topology used in DC to DC converter? Buck converter, boost converter, playback converter, all of them are used, right? Okay, this is question from the communication. What is the average probability of error with two symbols 0 and 1 with source probability 0.2, 0.4 respectively, transmitted over a binary asymmetric channel as shown in the figure? So we have to calculate the probability of error. So probability of error is coming out to be whenever you send a 0 signal and you will receive a 1 signal. So that means 0.3 multiplied by probability of sending of 0 plus when you send the 1 but you receive the 0, right? That will be 0.4 multiplied by the probability of sending 1, 0.8. When you multiply this one, you will get 0.38. The minimum distance required to a linear blow code to achieve a guaranteed correction of up to 5 error. So whenever the minimum distance should be 2t plus 1 and t will be 5, so the minimum distance will be 11. Yes. The lower threshold point voltage of a Smith trigger with an ideal operational amplifier is shown in the figure. So whenever we are calculating the lower threshold will be calculated with this -5 whenever you have the lower voltage. So that lower threshold LNTP, lower threshold point will be this resistance in the numerator. We are using the voltage division rule. We are calculating the voltage here. That will be the lower threshold point and upper threshold point. When you are calculating the voltage lower threshold point, you have to use the voltage division rule because the 0 ampere current will go inside the op amp. So we can directly apply the voltage division rule. 5 divided by 5 plus 10 into -5. So that is going to be 15, and 3, that is -5 by 3, that is going to be -1.667. Answer will be T for this question. Ideal comparator fed with a sine wave of 4 volt and DC component as shown in the figure. The reference voltage of the comparator is 1 volt. What is the duty cycle of the output waveform? See, basically this question is like this. We are having a input sinusoidal wave like this. That is having maximum value is 4, that is having minimum value as -4. Now he is saying what? We have to be a comparator which having reference value of 1 volt. So just make a line of reference 1 volt. Right. Whenever your input go above 1 volt, your output will be, the output waveform will be, I am drawing the output and waveform. This is reference. Let's draw the output waveform. Yeah, that output waveform will be let's take minus VCC, and then it will go plus VCC, minus VCC, plus VCC like this. So this is your output waveform. We have to calculate this T on. This is called T on, and this is called T off, the complete cycle, up to the complete cycle, that is called as T off, right? So we have to calculate the T on. So whenever your input voltage is greater than 1 volt, input voltage is greater than 1 volt, that is T on time. So what we can calculate? Okay, that is peak to peak. Oh, peak to peak, that will be yeah, this should be 2 to -2, right? Not -4 to 4. That should be -2 to 2. Yes. So that will be 30 degree. You already know this is half of this one, that is 30 degree, 120 degree, right? So if we calculate the T on is going to be 120 minus 30 divided by 360. So how much is that one? That is going to be 25%, I think so. 1 by 2, the solution will be pi by 6, 30 and 5 pi by 6. Yeah, that's my mistake. That's my mistake. That is not 120. That is 150. That is 150. Yes, that is 120 by 360, 200. So 100 by 3, 33.33%. This one has a capacitor at the input side, right? And at the feedback we have a resistance. So basically this circuit will work like a differentiator, right? And that the value of the output voltage is minus RC d upon dt of the input voltage. So basically what we have to do, RC is given to you 1. So we replace this RC by 1, that is going to be minus, and that is derivative of the input wave. So when you take the derivative, this line has a slope 1, that is going to be -1. So at -1, then this cycle, the slope is negative, then minus is outside, that is +1. So answer will be B here. So you have to take the derivative. Only derivative will give you the slope. This slope is positive because we already have a negative sign outside, that will make that -1. that is plus 1. This is the question from the gate exam, last gate exam they asked this questions, right? Oh sorry, that will be RC here, not 1 upon RC, right? RC. A 8-bit digital to analog converter is using two identical 4-bit DAC with equal reference voltages as shown in the figure. If B0 represents the LSB, B7 represents the MSB, the op-amp is ideal to obtain the correct analog value corresponding to an 8-bit DAC at the output voltage. What should be the value of the resistance R? So we have to choose this value of this resistance R. See, basically this is 16, right? This should be 4 times of that value. That should be 64, not 4 times, divided by 4 times, right? Like that. Yes, you can check it here. Yes, that will be minus R2 by R1, and R1 is given to R1 we have to calculate, R2 will given to you, that is 16 by R. We have to choose this value to get the correct output. So R should be 1 because this is having higher bits, that is 4-bit higher bit, that should be the having value 16. So that is 16 divided by 1, that's why that will multiply by the 16 value, right? So what we can say, that should be 1 kilo ohm, not 0.5. The answer will be 1 kilo ohm. Which of the following is the error transfer function of a negative feedback system? See, whenever we are talking about the negative feedback system, the error is basically the error signal divided by the input signal, right? Let's take xs, that will be 1 upon 1 plus gh. So directly answer will be A. Yeah, the following system is stable or unstable, so just find its pole. So that will be 4s square plus 1 is equals to 0. So s square is equals to minus 1 by 4, right? S value is going to be plus minus j 1 by 2. That make this system as a marginally stable because the poles are lying on the j omega axis. The Bode plot of a delay transfer function e raised to the power minus 3x has the following shape. See, basically whenever we are talking about the Bode plot of a delay element, there are two plots in Bode plot. One is magnitude plot is constant, but the phase plot will have a linear decay, right, with the negative slope. So answer will be straight line with negative slope, that will be in phase. Remember that will not in magnitude will be constant, that will only have in the phase plot. What is the correct statement of Cauchy residue theorem due to which next criteria? Number of poles, yeah. So the closed integration g dot ds should be equals to 2 pi j number of poles minus number of 0 m minus n, that will be p minus z. When converting the following system into the standard state space equation, so what should we do? We first assume that x1 dash is equals to x2, right, and x2 dash is going to be how much? 9 times x1 minus 3 times x2. We assume that x1 is equals to what? X, right? x2 plus 3 sine of omega t, and then when you convert this one in the form of matrix, that will be x1 dash x2 dash, that is 0 1 9 minus 3 x1. So this will be your a value. So a is going to be 0 1 9 minus 3. The answer will be B. 0 1, sorry, not B, C. 0 1 9 minus 3. Whenever you, this is the directly condition he is asking about the controllability. When we are talking about the controllability will depend on A and B. That will be B, AB, A square B. So answer will be A here. Standard form of PID controller. So basically PID controller is proportional means Kp, then integral means Ki over S, and then the derivative Kd into S. So which one is the correct answer? Answer will be C. The standard second order polynomial is given to you according to Rao criteria, the stability condition. See, basically this question has two options because it is a second order polynomial. So the coefficient of each term should be having same sign, should have same sign. So basically either they are positive or either they may be negative. So A and B, both options are correct, but I think he will give you the only A answer, right? But for B answer it is also correct, right, if it is a stable. Yeah, two infinitely long wire are separated by a distance of 5 meter carrying a current I in the opposite direction. They are carrying the current. This one is current is going to be inside the paper, this current is coming out to be paper, right? If I is 10 ampere, then the magnetic field intensity at the P point, we have to calculate the magnetic field intensity at this P point. So basically when you are calculating the magnetic field H, that will be the sum of H1 plus H2, right? Due to this one downward, due to this one also downward. So we have to add both of them. As we know, the magnetic field H is I upon 2 pi r, right? So if I calculate the total, that will be due to first wire is 10 divided by 2 pi r is 5, not 5, this time is 4, because we have to calculate the distance between these two things, right? That will be 4 and this distance will be 1, and the second value is 10 divided by 2 pi into 1, so that is going to be 50 upon 8 pi, right? So answer will be A. The characteristic impedance of a transmission line is 50 ohm. The input impedance of a open circuited line is this, the short circuited line. See, what will be the relation? The characteristic impedance square is equals to short circuited impedance, open circuited impedance. So when you calculated the short circuited impedance, that will be Z0 divided by open circuited impedance. So it's going to be 50 square divided by 100 plus J 150. When you solve it, 7.69 plus, not plus, that will be minus 11.54. The answer will be A. The characteristic equation of a closed loop system is, then the system is, so compare this one with S square plus twice of zeta omega ns plus omega n square equals to 0. So omega n is going to be under root 2 and twice of zeta omega n is equals to 2. So what we got, zeta is going to be 1 by root 2. That value is 0.707, which is less than 1. So we can say this is a underdamped system. A 12 volt battery discharged from for 20 minutes at a constant current of 2 ampere and the terminal voltage drop linearly from 12 to 10. Okay, the linearly it is dropping from 12 to 10 in 20 minutes. So the total energy delivered by the battery during this time. So first we calculate the average voltage, that is 11, and the average power, that is V into I, that is 11 into 22 volt, and when you convert this one into energy is 22 multiplied by the time is 20 minutes, convert that into second, that is 20 into 60, that is 1200 seconds. So that will be 26.4 kilojoule. I1 is equals to 10 ampere. Calculate the value of Vs. We have to calculate this Vs value, and I1 is given to you. See, basically from this output side, what we are seeing, this I1 is equals to minus of 2i's of V1, right? So I1 is given to you, that is 10 is equals to minus 2 V1. So V1 is going to be minus 5 volt. So we got the value of V1. Now from this input side, what we are seeing, that Vs is equals to V1, so the Vs value is going to be minus 5 volt. So answer will be A here. Find Va. Yes, to do this, first what we have to do, we have to use the source transformation here. that will be converted into a voltage source. I convert that plus minus, so that is become 64 volt. This is 8 ohm, this is 2 ohm here. Now we will have the this one, and we will have a resistance here, 16 volt, 5 ohm, 10 ohm. Now we have to calculate the voltage VA here. Let's take this is the reference here. So I make this circuit like this by changing this current source into voltage source. Now I can apply the nodal analysis there. That will be VA minus 64 divided by 10 plus the second one is VA minus 16 divided by 5, then plus VA by 10 equals to 0. Now you can solve for VA. So VA is going to be 1 by 10 plus 1 by 5 plus 1 by 10 is equals to 64 by 10 plus 16 by 5. So basically this value 1 by 10 is 1 by 5, 1 by 5 plus 1 by 5 is 2 by 5 times VA is equals to, basically this is when you take the LCM, that will be 10 here, and this is going to be 32 plus 64, 96, so that will cancel, that is become 4. So VA is going to be 96 by 4, that is 24. Answer will be 24. That should be 24. 96, 24. V answer is 24, right? Correct. Answer is A, not B. Answer will be A, 24. For obtaining the maximum power from a solar cell, it should be operated in which portion of its VI characteristics? That should be operated in knee point, right? Optimal operation, that is in knee point operation, like that. Commonly used thermistor for temperature measurement has the negative temperature coefficient. The change in magnetic flux in a coil is of 30 turns is 0.1. What will be the EMF? EMF is minus N d phi by dt. So that is going to be minus 30 times 0.1, so minus 3 volt. Answer will be B, not A, that is B. Neglecting saturation. If the current taken by a DC series motor is increased from 10 to 12 volt, the percentage increase in torque. So that will be the torque will be directly proportional to I square. When you take T2 upon T1, you do that, you will go to 1.44, and that means that there is an increase of 44%. Answer will be A. Next question. A DC shunt generator produces 450 ampere at a 230 volt. 230 volt. The resistance of shunt field armature is 50 ohm and 0.025 ohm respectively. The armature voltage drop will be. So whenever we are calculating, the first thing what we have to calculate, VT is given to you, load current is given to you, shunt resistance and RA, all the values are given to you. So first what we have to calculate, the shunt current, that will be ISH. This is going to be 4.6, and the armature current, when you draw the equivalent for this one, this is your motor, means motor symbol here, we will have the resistance is like this, and this will be your load here, that is IL, ISH, sorry, IA, ISH and all the current. So what we can say, the IA is always equals to IL plus ISH, shunt current, right? So we will go to the current is armature current, that is 454.6, right? And armature voltage drop, armature resistance plus, multiply by that current. So we will go to 11.365. So 11.36 will be the correct answer for this one. The rotor current frequency of an induction motor is operated at 50 Hertz with slip of 4% is. See, whenever you are calculating the rotor frequency, that will be slip multiplied by the input frequency. Input frequency or operating frequency is 50, slip is 4%, so 0.04 into 50, that is 2 Hertz. In chopper circuit, the thyristor is switched off at regular interval by adopting the force commutation, right? When bridge is commonly used to measurement the capacitance, that will be used to measurement the capacitance. Yeah, Q factor of a coil is given by XL over R. Answer will be A. And the last question, after firing the SCR, if the gate pulse is removed, then the current of the SCR remains same, that current will not change. So these are the technical question which was asked in the ISRO exam in 2023. I already discussed all of these one. See, basically if you want to prepare, because ISRO released the notification and form are still start filling for the ISRO, right? If you want to prepare for ISRO exam, you can join YourPedia Education. We are going to launch the bench for this ISRO. So hopefully this solution will help you in your preparation of this ISRO exam. Thank you.